Welcome back to the June edition of NMRAx. Unfortunately, today we have a shortened version. Two cancellations. I think too much summer, too much swimming, too much beach time. So we do what we can do. Our presenter for today will explain how we built the Anohaqui station. He lives in Moncton, New Brunswick, and serves as AP chair, a board member, and coordinator for the monthly third Thursday seminar series for the Eastern Canada division of the Northeast region. His primary modeling interest is centered on the Canadian National Railways and he enjoys building rolling stock and structures from scratch and kits. James has been an NMRA member since 1971 and he holds the, still under warranty, MMR 720. Welcome, James.
Well, thank you. Good morning, Speed, and thank you for the introduction. So today I'm going to be talking about a very kind of involved project that incorporates laser cutting and conventional model building. I did this 2 years ago, and I wanted to challenge myself with some new techniques, and I found overall to be very worthwhile. Now, I don't expect that everybody watching is going to want to build an exact copy of what I did, but my hope is that you would pick up a few techniques that you might be able to use in your own project. And every project is really a series of mini projects, and there might be something for you here. So continuing from my presentation 2 months ago, photo interpretation for model makers, I'm going to summarize how I took the raw field measurements of the Anohaqui, New Brunswick CNR station all the way to a completed model. And I made the drawings based on the field measurements using computer-aided drafting software. And it also therefore enabled fabrication of many of the principal parts using a laser cutter. So the laser cutter parts were then supplemented with many traditional hand techniques in model making, including finishing using conventional brush and spray painting as well as chalks. So even if you don't plan on trying laser cutting, there's lots of other items in here that may be interesting for your own projects. So if you recall from my previous presentation, I went out to the prototype structure, which has been preserved at the Agricultural Museum of New Brunswick. It's been there about 30 years and they've restored it to beautiful condition. And we received permission, we being my wife and I, to go down in 2021 and take a very detailed series of measurements. So just to recap from my photo interpretation presentation, taking photos from a previous visit and printing them on 8.5 by 11 paper is a really, really convenient way for taking field measurements, and you can mark your measurements right on the photo. And it saves having to make drawings and sketches on site and possibly introducing more errors than you would with a photo. So this is a really handy, convenient method if it's possible to do it. So all these field notes were organized and used to create a drawing of the elevations in plan view. As I mentioned, I use CAD software, which is necessary if you're going to do laser cutting. However, you can use other vector-based drawing packages if you don't have CAD per se. I happen to choose the DraftSite program by Dassault Systèmes. They're the people that do SolidWorks and several other very useful programs. This DraftSite was recommended to me by a friend who used it in actually aviation design, and lots of alternatives are also available. The good thing about DraftSite, it's very compatible with AutoCAD, but it's only a fraction of the price. And I'm currently using the standard basic version of DraftSite, and the annual license renewal fee is currently $171.18 Canadian, which I think is around 120 US. However, I believe that new users are now being offered DraftSite Professional at $299 US per annum, or the advanced premium version at $599, which includes 3D. I think I might be grandfathered into the standard version, but anyway, it's still cheaper than some of the alternatives. And you could actually think of the cost of the software as the price of a locomotive, and it does quite a lot more. This is the draft site screen showing the main elevation drawing I prepared. These are just a whole series of screenshots that I took. And the control buttons at the top are similar to other CAD programs. The command window at the bottom left is very functionally similar to AutoCAD for those who are used to AutoCAD. And actually, once you get used to it, using the command window allows the work to go much faster, because essentially, these are very, very powerful programs, but we only need to use a certain amount of it. It's no different than a word processing program. How many people actually use all the features in Word? So once you learn the few relatively basic commands you need for model railroad type drawings, they have a shortcut name with either anywhere from a few letters to a complete word. So you can type them in the command line prompt and it goes very, very fast. So I actually use my left hand for the commands, and I use my right hand for the mouse and the return key. And any previous command that you just used sits there, and if you want to reuse it again, you hit the return key. So it's very, very convenient to use once you get used to it. So here's a close-up of the front elevation of my station. And like all CAD programs, DraftSite includes all kinds of standard features for manipulating drawings, such as zoom and pan and so on. So here I've zoomed into the front door, and then I've zoomed into the door handle, and it's very easy to see what you're doing. One thing I want to comment on is that the CAD program allows you to enter whatever scale you want to work in, but actually the best, most flexible way to do it is to work in full-size 1-to-1 scale. So if the building is, so many feet wide, you enter that directly. So the computer thinks you're drawing a building, 40 feet wide. And if you went to print that, it would try to print out 40 feet of paper. But we're obviously not going to do that. The beauty of working in 1-to-1 scale is that when you go to print the drawing, at the time of printing, it asks you what scale you want. So in our case, if we're working in 87-to-1 scale, 87.1 for HO scale, you select that and out comes the drawing. If you want to make another drawing in O scale, you put 1-to-48. So that is a clue as to why, for example, kit manufacturers of laser cut kits can so easily offer the kit in multiple scales. So it's a very, very flexible feature. And one thing that I want to mention is that a lot of articles in the magazines, the commercial press, dealing with 2D objects and 3D printed objects really skip over the underlying software. A most recent article I read in one of the magazines had one sentence devoted to the fact that the person made drawings. Now, I can't possibly in a 1-hour seminar cover all you need to know in order to how to use a CAD program. But what I want to do is just give you a little flavor of some of the basic things, and perhaps it will prompt many of you to go out and try this. And a lot of these companies, including Dassault Systèmes, offer 30-day free trials. So you can easily get your feet wet without committing any money. And libraries sometimes have these facilities, along with laser cutters and 3D printers. So in this case, there's a very good command reference in DraftSite, and if you press F1 on the screen, on the keyboard, you get a pop-up window that looks like this. And if you are familiar with AutoCAD, many of the commands have slightly different names, but they function the same. So obviously, people paid close attention to what they were doing. And as I mentioned, once you memorize the commands you actually need, it's a faster process. And I mentioned about hitting return. Now, to do something basic like draw a rectangle, you can use the line command, and you can draw a rectangle with 4 lines. And then you can use something called the trim command. So you highlight a certain line, and then you clip off the extensions beyond that line. And the line that you're trimming comes up in blue in this case. So that's a very basic thing you can do. Now, there's also a rectangle command that allows you to draw a precisely sized rectangle or square or any other object. And the abbreviation in this case is RECT on the command line. And it asks you how many units horizontally and how many units vertically you want to make your rectangle. So if you, for instance, have a boxcar door and it's 6 feet wide and 9 feet tall, that's how you would be able to do that if you wanted to. Now, there's another command which is particularly useful for model railroaders. We have all kinds of buildings with clapboards, shiplap siding, tongue and groove siding on freight cars, passenger cars. So there's a command in there called offset, and it's very, very handy and easy to use for making parallel lines. So you basically select the amount of offset. In this case, I chose 3.5 inches. You click on the line you want to offset from, and then you click to the side of the line you want the offset to go to. So once you get the hang of it, it just goes click, 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 and you can fill in the whole side easily. There's another very useful command for model railroading called the array command, and it's very handy for things that have a lot of repetitive nature. For instance, a multi-pane window. So you would first draw one window pane, and then you select it, and then you call up the array command, and you get a window that pops up. And if you look on the center of your screen, you'll see part of the window that says settings, and it says number of elements on vertical axis, in this case 3, number of elements on horizontal axis, in this case 3, and the spacing between elements, in this case, is in inches. So it's actually the spacing from the left-hand ordinate of the object. But basically, you set up, in this case, I want 3 high and 3 across. You say, OK, boom, you get the whole window in one go. And if you have your frame, you can draw a rectangle for the frame and the molding trim and everything, and then move this set of window panes into the frame. And then you can save the entire window as one object, and then you can copy and paste the whole thing as many times as you feel like. So it's a very efficient process once you do a little practice. So here's an example in the center of the screen, a close-up of the side elevation of the station. And I've zoomed in on the roof bracket. Now, the roof bracket itself was a fairly involved thing to draw because of all the shapes and curves and everything. But again, you only do that once, and you populate your drawing with that. Now, this is a feature that I wanted to have laser cut. So I extracted from the main drawing. And what I mean by that is I selected the roof bracket as one object, and I brought it into a blank page of the drawing or another drawing. And then I used the rotate command. I copied the bracket. I rotated the bracket 180 degrees and brought 2 of them together. And then I selected the pair of brackets, one right side up and the other upside down. And I used the array command to produce an array 4 across and 5 down. So right there, that's your basically your complete fret for the laser cutter. And on that drawing, with these brackets, you can't have any other lines. You just have, for the laser cutter, the actual edges of the pieces you're going to cut out, and the rest is waste. But that only takes a couple minutes to array that and get that ready. Now, another example of getting files ready for laser cutting is the windows. So this is the main front window, and I drew the sash, or actually the trim, as one piece. And to give a 3D effect on the final model, I made some extra edges of the sill, which come on. They're cut as separate pieces, but I just glue them. I made extras. I only actually used 2, I think, to bring the sill out towards you to give the window a 3D effect. The prototype window had a cornice, which looks like the drawing at the very top here in the center. And what I did is I broke it down into 3 shapes. So the bottom of it is here, the middle piece is in the middle, and the very top edge is here. So when those are cut out, you simply glue the 3 strips together right over top of the window, and there's your trim. You'll see on the right what the complete window, including the sash and muntins, looks like. The muntins were drawn all separately, and I designed the file so that the top sash overlaps the lower sash as it is on the prototype. So the prototype windows were set up in the usual way, where the lower sash slides up behind the upper sash. So once you get all these drawings ready, you scale the whole file to the ratio you want for your model. In my case, it was 87:1 for HO. So that file is now in HO scale, and you send it to the laser cutter. It could be in a PDF, it could be in a DXF. There's several files, that different file types that different laser cutters can receive. So the machine takes whatever it sees, and it cuts all along every black line, and out come the parts. So this is on the right, a photograph of what the laser cut fret looked like after the roof brackets were cut. And you can see every one of them is exactly the same. So imagine, I made more than I needed. I probably made twice as many as I needed in case of problems or whatever. But imagine making all those by hand. A lot of steps involved. Now, a very important thing about the laser you have to be aware of is that the laser beam burns off a little bit of the edge of the material as it cuts through each part. And that's no different than the kerf of a saw blade. So for miniature parts, you kind of have to go through a trial and error testing process to establish how much of a small allowance needs to be added or subtracted around each drawing feature to compensate for the laser kerf. Now, people with newer laser cutting machines are using various types of software. One of them is Lightburn, which actually has a feature that does this kerf compensation automatically. And some older programs lack this capability, which is something to watch out for. And if the program lacks this capability, you basically have to add the allowance yourself. And that can be done using the offset command, but it's a lot of work. And if you don't have to do it, you can get Lightburn. I recommend that highly. Now, in this case, the laser margin turned out to be 5.5 thousandths of an inch, or about half an inch in HO scale. Now, I can hear everybody saying, that's nothing, why bother? Well, it turns out on very small parts, especially parts like windows that have to fit together, this does matter, because you could make the sash basically either have a gap between the frame and the sash or be too big to fit. You end up filing or filling or things like that. You don't really want to do that. Larger pieces like walls, roofs, things like that, it's irrelevant. But for very close fitting parts, you do have to take into account the laser curve. So this is an example of the complete set of parts for the model. The windows and doors are cut out of 1/32. Actually, they're not. They're cut out of a material used in cabinet making called backer board, which in the hobby is sometimes referred to as laser board. And it's basically a resin impregnated paper that's laminated to the inside of commercial kitchen cabinets to limit warping due to the wood veneer on the front. So they typically put a good quality wood veneer on the front of the cabinet, but they use MDF or particle board in the core of the door frame, and they need to seal the back with something that's going to equalize the warping stress so your doors don't warp. And it turns out this is a very, very interesting and tough material compared to styrene or wood. It comes in several thicknesses, and parts cut using backer board using a laser have very, very crisp, precise edges. And so it's a really ideal choice for windows and doors. Now, the rest of the model was cut out of basswood sheet of 1/32 and 1/16 thickness. You can see the roof brackets. This is the chimney. These are the floors, then the wall sections, and finally the roof sections. On the left in the upper right photo are the shingles. So I basically drew two types of shingles. I drew the cedar shake shingles that are often used on the sides of older buildings. I drew one pattern, and then I kind of randomized it and cut and paste a lot of times until I could fill an 8.5 by 11 sheet. The other set of shingles were asphalt shingles. I ended up not using them. I'll tell you more later. Now for assembly, at this point, you've basically produced a custom-made kit. So all the wall sections were removed from the basswood sheet and labeled, so I knew where they went. And after I drew all the wall pieces, I decided that I would put a complete interior in the model. So rather than going through all the drawing process again, I just simply glued on some northeastern scribe siding and plain sheet wood, and then I just cut out the windows using the laser cut openings as a guide. Now, if you're doing this all over again, probably do the whole thing in laser cutting. But I have a small modeler size table saw, and I can cut sheets very, very quickly. It has a very thin blade, which is similar to the blades they use in cutting casts in the medical field and things like that. So it's a handy thing to have, but you certainly don't need to do that. You can just use a straight edge and a single edge razor blade or an X-Acto knife, as I've shown. So to get the window and door openings clean up, a method I've used for years on structures generally is to cut a piece of tongue depressor or sheet wood the exact width of the opening you want to clean up, and then just glue a piece of sandpaper to it. So it's like making a custom-made sanding stick for that particular application. And it happens that, in this case, I think I had something like 17 windows, and there's a lot of similarity between them. So it's worth making this up. And you can sand the whole width a lot easier without having peaks and valleys appear if you're using a sanding stick or a file that's too narrow for the opening. It's harder to control the squareness of the opening. And this works on styrene too. Highly recommend doing this. Now, the wall corners in the case of this project were mitered at 45 degrees, and I glued them together, which is actually giving you a fairly strong joint. If the model does not have an interior, you can just use bracing. Now, you may ask, what about warping? What about interior bracing of the model? Well, it happened that I purposely oriented the grain of the outside laser cut piece of wall part to be 90 degrees from the grain of the horizontal inside sheathing. So it's like a piece of homemade plywood that's laminated together. And it turns out to be very resistant to warping. And even if you're making a model that has nothing to do with laser cutting, but you want to have a wall that's, say, a 1/16 of an inch thick, use two 1/32 inch pieces with the grain oriented at 90 degrees, and the whole wall will be far stiffer and more resistant to warping as a result. Now, what I'm showing in these photos is a method of filing miter angles or sanding miter angles. So I've got a piece of 2x6 that I cut on a table saw to give a 45-degree angle, and I put some horizontal guidelines, and I just hold the side to be sanded against the edge. And right here is a long piece of hardwood flooring that I glued 2 grades of sandpaper on. I think I have 120 and 240 there. And you just make a very even 45-degree angle. The similar method is also useful for making very square 90-degree angle or 90-degree corners for pieces that need it. And it's simple, costs almost nothing to do. Now, the various parts like the doors and so on were cut out in the usual way after the laser cutting was done. So this would be no different than receiving a kit of parts at this point. And since I was doing the interior, I stuck all these parts onto a piece of masking tape and airbrushed them. I'm strongly in favor of airbrushing, or it doesn't matter actually if it's airbrushed or brush paint, but I'm strongly in favor of pre-painting as much as you can. And that way you save on masking, you save on having to have color separations that are hard to do, masking in difficult places. It's just a lot easier to pre-paint everything. Now, one other point here, you'll see that this little interior wall partition is sitting on a hardwood block. I use the hardwood block for a lot of things. And if you look very carefully, you can see some lines drawn on the block. And this line here is at 45 degrees. So if you want to make trim and you want to cut a simple 45-degree angle, you just lay the strip parallel to the edge of the block and you cut the corner along the line with a single edge razor blade. Boom, you've got your 45-degree miter angle. It's very easy to do. Doesn't cost anything except find a little piece of scrap hardwood. So I also pre-stained the floor, and anything else that I could pre-paint, I did. And you can see the interior is starting to take shape. And something useful as well is I have a piece of plate glass inset into my workbench top, and I rest a cutting mat on it. So this surface is very flat. It's not machinist surface plate flat quality, but it's plenty good enough for model making. And you'll find that when you're jigging up parts, everything will be square and level. Now I made the roof base so that the roof is removable, and I want it to have, there's a lot of interior and exterior lighting on this model, and I didn't want unsightly wires hanging around. So what I did when I was making up the interior wall, I incorporated a couple of pieces of phosphor bronze wire from Tichy right in the wall, and those form electrical contact pins. And I had some phosphor bronze strip, and I bent it up into a couple of leaf spring contacts, which touch these wire pins when the roof goes on. And because it's a leaf spring contact, it has what we say in the electrical field, a bit of wipe. So it avoids contact, single point contact problems that could oxidize and make a poor contact. But this is a very, very simple thing to bring your power through. If you want it to, you could do that on the bottom and have the structure plug into your layout. But in this case, I have a slight recess under the floor and I have just regular wires under there. So I framed the sub panel, the subroof, and these are all triangles that I cut using the laser cutter. And if anybody's done a structure from scratch and you've tried to cut roof panels by hand, it's actually not a totally simple job. So having them drawn up to accurate scale using the CAD program was a lot of benefit in this case. And I just added a whole bunch of extra interior partitions. It's the same way you'd build a model airplane or model ship in a way, just to give enough support for the roof. And I took a little piece of electronic perf board and I added a whole bunch of resistors so each LED can have its own resistor, and I just tucked that in a spare opening, and I left a removable slot, so if this ever has to be serviced, it can come out. So you can see this slot that I left, and it's recessed into the underside of the roof with a couple of tiny screws that you can't see when you're looking at the model through the windows. But I don't anticipate a problem with this. The model roof is interesting. The prototype has a flare in the roof, which is at about a 5-degree angle to the main part of the roof. Many railroad stations have this kind of architectural feature. So I made a little jig with a 5-degree angle in it that I made out of scrap styrene to help set the angle. If I had to do that over again, I would do it differently. I would make a small platform to sit the main part of the roof on, and then I would let the edges of the roof come down to the level bench surface. But for something that you're going to have removable, could be on a structure, a passenger car, could be anything. All I did was I taped wax paper. I carefully folded and taped wax paper to the main part of the structure so that the pieces would not be stuck to the main walls as they are glued together. And the whole thing comes off with a very nice slide fit. The thickness of the wax paper isn't much, but it's just enough to give a nice slide fit so the roof can come off later. Now, I wanted the old-fashioned pendant lamps. You can buy them in the hobby. Most of them are too large unless for HO, sold as HO. They're probably more accurate for O scale. So I have a couple of lathes. I have a little, very small lathe and a larger lathe. So I use the small mini lathe to turn lampshades. And you can see this is looking straight down at the workpiece. There's the tool post. There's the cutter. And you can see the shape of the lampshade developing. And I bought small warm white LEDs on the internet that had leads installed, and there you can see the small LED test fitted in the recessed opening. But by all means, if you feel like it, purchase these parts. They don't even have to be working. Now, I mentioned the cedar shake shingles, and you can see in the top photo what they look like after they're pre-painted. So these were the papers, the 8.5 by 11 sheet of paper that was laser cut into strips. So it's basically the laser cut version of Campbell profile shingles, which very sadly are no longer available. And they're almost very dear to get at train shows, swap meets. The lower part of the station had clapboards up to the windowsill, and then the upper part of the walls had cedar shake shingles. So I stained them I stained the clapboards with a very thinned mixture of Floquil boxcar red, which a friend of mine refers to as unobtainium. And the thing you have to be careful about is On paper and wood, acrylics can cause warping, and I don't recommend them at all. Now you may say, well, why not prime the stuff first and then put acrylics? The problem is that the stain does not absorb naturally at that point and produce the natural variations that we're looking for. If you look in the lower photo, you'll see that the wall shingling and the clapboards is not uniform. And the prototype is not uniform unless it's been just painted 2 weeks ago. So once the sun gets it and the wood absorbs paint differently and so on and so forth, there's a variation, and this is a really simple way to do it. So before I separated the cedar shakes from the big sheet, I just sprayed randomly with the airbrush, and I didn't try to make the coating uniform. And then as I apply them to the model, I just chose them at random so that they're not coming out in any particular order. And once I did that, I had the laser cut door frames, window frames, and I pre-painted those as well. So all you have to do is locate them and attach them. And if anybody is a Canadian National Railways fan, something recommended to me a long time ago was Humbrol Enamel Matte 103 Cream is a good match for the CNR trim color. Now, for the roof brackets, these are the little roof brackets I showed earlier. I wanted to make them more secure on the model, so I made a little jig to drill 2 holes exactly in the same location in each one, and I put 2 pins in each. And I made another jig with 2 holes that located them at the exact location on the model. I took these dimensions straight off the drawing. Now, what you can't see here is along the top of the roof, I mark the center line, or sorry, on the top of the wall, I mark the center line to locate each roof bracket. And you'll see a very tiny guide notch in this line. So all I did was I placed this little jig at the required location. I drilled 2 holes partway into the wall. And then I super glued 2 pins in each bracket and put them on. In this case, I didn't use super glue on the finished wall, however, because it tends to wick and bleed and it will ruin your exterior finish. So I used, for the actual final attachment, I used 2 tiny drops of 5-minute epoxy. But, you know, making jigs like that is a fantastic time saver. Many people think, well, I don't have time to make a jig, I just want to build a model. But once you make a jig, you can go very quickly and accurately, and you're not ending up trying to unglue parts you put in the wrong place and so on and so forth. So there you go. Now, I did mention that I had laser cut the asphalt shingles, but I decided that where the roof was so visible, and to get a really scale appearance of the shingles, I decided to use an old method that originated about 60 years ago. I think it was from Gib Kennedy or Jack Work in their model railroad articles from the late 50s or early 60s. And first thing I want to mention is that you can buy lots of commercial products for shingles. I find a lot of them are cut on material that's too thick, except Campbell profile shingles. And there may be others that I'm not aware of that are closer to scale, but some of the ones I have seen are definitely out of scale. So what I did is I took a piece of 8.5 by 11 copy paper and I sprayed it with a couple of shades of gray. And you don't want black, but dark gray. And if you're representing black shingles, if you're using another color of shingle, of course, choose whatever color you think is appropriate. But it has to be a matte finish paint. And you spray the paper randomly. Notice in the upper photo that the paper I'm cutting off is not uniformly cut. We just absolutely don't want uniformity. And You also want to spray from a distance so that the finish has a slightly rough texture that normally in airbrushing models we find undesirable, but here it's very desirable. So you take your scale ruler and you offset it 6 inches from the edge of the paper. And every foot you make a small slit with the knife. So 3-tab shingles typically have 12-inch tabs. And yes, this is a little bit tedious, but once you get the hang of it, it's kind of repetitive, mindless activity. So you cut a whole pile of shingles, and you find that putting them on the roof with some horizontal guidelines, maybe every 3/8 or half an inch, helps your eye line them up. You do not need a guideline for every row, but every so often you need a reference line so you can prevent um, putting them on crooked. And this applies for any other separate shingle material, especially Campbell shingles. Now, my shingles here are not pre-gummed. I suppose I could have found some pre-gum paper and used that, but I have some ambroid cement which I saved from back in the day when you could actually buy it, and it's absolutely ideal for this kind of a job, paper to wood, because it doesn't cause any warping. It's a cellulose-based product. Uh, there is a present-day product that also works well. It's used in the jewelry trade for cementing watch crystals, and it's called GS Hypo Cement, and you can get it on Amazon or at a jewelry supplier. So once all the shingles are on, you cut them long, and then you trim them off, and then you make up. You take some of your extra left over and cut the 12-inch tabs off and bend them to make ridge caps. So this is what it looks like when it's finished. And the other thing that I want to mention is that once you're finished shingling, you're going to have a whole lot of white edges. So you take your airbrush and you spray very lightly from a distance up the slope of the roof against the white edges using the same types of gray paint that you used before. And very, very quickly you'll take care of that. Now the chimney was also laser cut. The prototype had a unique pattern. So I drew that in the program, and I also made a couple of extra strips for the cornice and mitered the edges at 45 degrees and glued the chimney together. The flashing is ordinary kitchen foil, very carefully cut out, and you'll notice that I've formed it into the contour of the shingles, which is what they used to do with lead flashing. And that's about it. Oh, one point I forgot to mention. In the case of the laser cutting, for this particular case, I drew 2 files. One had the brick pattern in it, and the other had the outline. So the laser cutting was done in 2 passes, but it turns out that newer software, such as Lightburn, allows the etching cut and the outline cut to be specified in one process. So you basically create a list. So cut number 1, bricks at, say, half power. Cut number 2, outline at, say, full power. And you just put the piece in, put your software in, and let her go. So it's very handy. Now, the windows were cut from microscope slide cover glass using a diamond tip scriber, and they were glued in place with minute amounts of the GS Hypocement, which happens to have an extremely thin needle tube applicator. So why use microscope glass? Well, it's a nice thing if you want to get very, very realistic windows that reflect light well. And it doesn't have the, or has better clarity than styrene. So how to cut it is, again, I have my hardwood block and I draw the outline of the window. And over here, the silver pen looking thing is actually a diamond tip scriber. And you can get them from Micromark or on Amazon or from a jewelry supplier. And you click out the point like a ballpoint pen, and you very, very gently trace the outline of the window using a plastic guide. Now, the diameter of the tip of the diamond scriber has to be taken into account. So you, by trial and error, you figure out how much offset you need to give your plastic guide. And then you just gently slide the glass over the edge of the hardwood block and just gently snap it. No force at all. It's very important to keep track of the scraps of glass. They're very, very sharp. They can get in your fingers. This is definitely a job for safety goggles. But you can buy the cover glass on the internet. Scientific suppliers sell it, and I think you can get it on Amazon. And I happen to clean it. I use lens cleaning tissues and ordinary eyeglass lens cleaner. And you just gently hold the piece with tweezers and put it in place. So you have to be a little more careful than if you were cutting styrene by the scoring and snapping method. But once you get the hang of it, it's very similar and it goes quite quickly. So I decided to add a bunch of interior details, and on the right here are the lampshades already painted and ready to go to have LEDs installed. And over here are some signs and posters and other interior features. So I carved the bathroom fixtures out of basswood, and I painted and sanded them. I basically measured the toilets in our house, and similarly made up some little sinks. The taps are little pieces of phosphor bronze wire soldered together. There's the toilet paper roller. It's a little piece of evergreen styrene rod with a little piece of 5-thou styrene on it, and the holder is a piece of wire. Trash can is a piece of K&S tubing. The operator's desk blotter is a little piece of cardstock. The safe is just a little block of wood with a couple of bits of wire handle. And the parcel scale is also just a couple of blocks of wood and a little disc of styrene. I made the brooms out of styrene and a bit of wire. The dustpan is a little piece of brass shim stock I bent up. I made the ticket case from stripwood, and the tickets and baggage tags are just little bits of color paper. I cut strips with an X-Acto knife and cut them all off. And the luggage is just little pieces of basswood that I carved to shape. And there's the brooms. I took the dimension off the broom from the one in the cupboard in our kitchen. And this push broom, I took the dimensions off the one in our garage. So it's kind of fun doing this because it's just the only limit is your imagination on what you choose to put in. The operator's desk is a representation of a typical railway operator's oak desk. I have a oak desk in my house, a much smaller one, and I took the dimensions for the drawers off it, and the drawer faces are just little pieces of stripwood. And it's stained with float stain, which is a beautiful stain, also unobtainable. The lunch can is a block of wood. That's actually a model of a Canadian National locomotive engineer's lunch can. And the blotter has little 8.5 by, or not 8.5 by 11, they're smaller size used on train orders. This little tissue paper, and I made some tiny scribbles to look like writing. The typewriter is a photograph I found on the internet, and it basically was glued to a piece of carved wood, and the green felt mat was a piece of cardstock stained with a marker pen. The telephone headset and transmitter were turned on my lathe. The accordion is a piece of brass mesh. The benches were made similarly using strip wood and stain with flow stain. So you can get carried away here, but I was having a lot of fun, so I had visited a lot of stations when I was younger, and all of these things, I had some photographs, but all of these details I mostly took from memory of what was required for an operator. Another interesting thing you can do with a CAD program or any other graphics program is make signs. And so I made a train bulletin for inside the station and outside. And I took the information from a 1954 Canadian National Railway timetable. So the people in the village of Anohaqui still had pretty good train service back then. The station signs were made the same way. There's all kinds of text fonts in the graphics program, and I found in this case that Arial font was the closest one for the CNR. And the advantage of CAD for this or another graphics program is that you can easily scale the lettering. In this case, the prototype numerals are 8 inches, so it was easy to get that right. A lot of stations had travel posters back in the day, and I found a lot of interesting ones on the internet. And in some cases, I had to bring them to HO scale. So I drew a rectangle of a typical size, 20 by 30 inches. There's other sizes used. And I stretched or compressed the image to fit the rectangle. But it turns out that if a actual physical piece of artwork was scanned at full size by the person putting it on the internet, when you import it into the CAD program, and if you're working in one-to-one scale, the CAD program automatically knows the size of the poster or artwork. So when you go to print it, you add your scale factor at that time, and it comes out exactly the right scale. Something neat I discovered. You can also import photo files into a CAD program. In this case, I have a painting, very old painting in the living room of the Ocean Limited, which was the famous train that's still running under Via Rail between Halifax and Montreal. And this was a photo from around artwork from around 1915. And I thought that would be appropriate for the station wall. So I photographed it, rescaled it, put it into the CAD program, and printed it out in HO scale. I found a picture of a railway station clock on the internet, so I rescaled it to HO and printed it, glued it on a piece of 1/32 wood, and trimmed out the wood. And I painted the edges to match the color of the wood finish on the clock. And there's a simple clock. So here's the completed model. And there's those lamp fixtures I was talking about, the roof brackets, the windows and doors. I added a little platform out front, and you can see some weathering I did with pan pastels. I colored the chimney mortar lines. I forget what I used for that, but came out fairly effectively. I added some bird droppings along the peak of the roof, and in the valley where water slows down, kind of added some moss shading with pan pastels. And it's hard to see in this photo, but there's some moss shading around the foundation. So there's the other sides. There's the signs added. The prototype soil stack for the toilet was originally lead, so it was streaking on the roof, and I put that on there. And I made a weatherhead for the power to come in. And there's a close-up view of the front right corner. There's an example of the window cornices. These windows on this side had the cornice, so you can see, if you remember, I described how I made these in layers and reducing size. So I just simply glued the 3 pieces together to make a cornice. And similarly, all the windows have a sill. So you can see the extra piece I glued in front, and there's your windowsill. And you can also see how the upper sash projects out beyond the lower sash. So the lower sash on the prototype could slide up and down. There's the interior, and you can see in the upper left corner the operator's office. There's his clock, the phone, the typewriter, everything is there. The safe, there's the ticket case. There's the washroom, the ladies and the men's. There's the storeroom. It has electrical meter and it has the brooms and dustpan. Here's the benches in the waiting room and the luggage. Over here is the weigh scale and another parcel waiting to be weighed. There's a close-up. There you can see the ticket case and the operator's wicket for the selling of the tickets is also made out of a little bit of brass mesh. There's a close-up of the washrooms. There's the interior chimney that went up through the building center. And there's the waiting room with some of the posters on the walls. There's the weigh scale. Now, a very sharp friend of mine commented that I had a parcel on the scale, but the scale was reading 0. So I should have had the arrows pointing to some other place on the scale. So my bad. I made a boo-boo. There's the interior lit up with the LEDs and the exterior. So it'll be great on a layout with the night scene. So to conclude, preparing drawings for laser cutting does take time, but the crispness and accuracy of the resulting parts, especially window sashes and roof brackets, makes all this worthwhile. A huge advantage of CAD is the ability to cut and paste repeated features, so that's a real time saver. Many commercial windows and doors are available, but for some railway architectural styles, there's a lot of uniqueness, and the Canadian National Railway is no exception. They had their own look, and it's up to you how close you want to go. Learning a suitable CAD program is straightforward with dedicated effort. There's a lot of tutorials available on the internet and general help. DraftSite is a very capable and relatively economical choice. There's lots of others. As you've seen in the presentation, laser cutting doesn't eliminate the need for many conventional model making techniques. However, some tasks like laying out a multi-pitch roof by hand and getting to the parts to fit is tricky, and the CAD work make this a much more accurate exercise. Including interior details on a foreground model adds a fun and imaginative dimension, and each piece can be considered to be a mini project all on its own. So just get out there and get started. I'd like to thank my wife, Annette, for helping me take field measurements of the Anohaqui station during 2 site visits we made in 2021, about 4 hours each. And actually, Annette contributed a measurement technique I discussed in my photo interpretation seminar. I'd also like to thank my sister-in-law, Jeanette, for her tutoring in DraftSite several years ago and helping me set up the program. And I'd like to finally thank my friend Alan Welch of Toronto for making his laser cutting machine available. So I emailed Al all the files and he very patiently cut them out, as I don't personally own a machine. So anyway, that's all, folks. If there's any questions, I'd be happy to try to answer them.
We have quite a few questions. Can you hear me?
I can.
So, what is the advantage of using a microscope slide cover glass instead of clear styrene?
Well, I find that it just looks much, much more natural. And even in the room lighting in your layout room, the reflections look natural. I find some styrene under certain lighting kind of has a thickness to it that doesn't look right. And sometimes it's not that pure. And it's worth trying the cover slide glass. As I mentioned, it cuts similarly to styrene, once you get the hang of it, and it's very cheap material. The pieces are 5 or 6 thou thick, but definitely keep track of your spare pieces and wear safety glasses. If you get that in the eye, you're kind of going to have a problem. So please don't
Ouch.
go there.
Could you have laser cut the asphalt roof shingles the same as
Yes,
you did the random cedar shake shingles?
yes. I just found the tabs looked a little too, like the spacing between the tabs looked a little too wide, and with a laser cutter, there's a physical limit of how fine it can go, and it has to do with the focusing of the beam and the design of the thing, and whether it's a $1,000 hobby machine or a $20,000 commercial machine that we would like to have, but we don't. And so it's just a choice I made. If I had to do it again, I probably would just use them.
Cool. You explained the white edges on the shingles. Um, would it helpful if you sprayed with a slightly darker color, gray, to show
Uh,
shadow or something?
you could. What I did actually to do that is I forgot to mention that when I was finished giving the edges of the shingles an initial quick distant spray to cut the white edges, I forgot to mention that I went over them with a couple of gray shades of pan pastel at random. Now, you got to be careful you don't get carried away, because pan pastels stick very well, as you know,
Hmm.
but you may recall that I mentioned you want to spray the roof a little bit rough so it
Hmm.
has a little more texture, and pan pastel really likes that texture a lot. So what I did is I took my short brush and dipped it in the pan pastel, and then I kind of tapped it out on a scrap of paper. So it's almost like dry brushing a dry powder, if you kind of will. And then I went lightly and shaded the roof shingles. So
Cool. Cool.
it's kind of nice to have multiple methods, and some people may prefer one or the other. Some people may want to produce a wash type stain. It's up to you.
Do you paint all the surfaces of the stuff you cut with the laser to prevent warping, maybe?
Uh, yes, and in fact, that's how the interior partitions and everything ended up. Like everything actually was painted on both sides. There are people who, even on a structure that doesn't necessarily have an interior and it's got all kinds of bracing, they'll take a rattle can, spray can, and paint the whole interior anyway. It's not a bad idea. But the first level of strength, if you will, comes from the fact that I oriented my wood grain. I used 2 layers and I oriented it at 90 degrees. So I kind of
Okay.
made miniature plywood.
Oh, cool.
And that in itself really resists warping. I've used that method quite a few times, especially on previous models that had large roof areas. So if you can find it in a hobby store, you can order it online. The plywood, so-called aircraft plywood, which is thin Baltic birch plywood, comes as thin as 1/64 of an inch.
Hmm.
So if you want a roof of a certain thickness, it's often convenient to laminate a couple of layers also at 90 degrees, even though it's already plywood. And it resists the warping problems we've seen with styrene.
And what do you use for glue there?
Oh, I used quite a bit of different glues, primarily for the walls and other features. I used Carpenter's yellow glue, and I dispense it on a little scrap of cardboard, and I use a sharpened toothpick to apply it. I did use some medium viscosity super glue for some of the wall parts. The medium viscosity gives you about maybe 6 or 7 good seconds to change your mind. Know what I mean? You can use the fast super glue, but you have no chance if you're wrong. So if it's something that can be held up with V blocks or 1, 2, 3 blocks or
Hmm.
square pieces of wood, then the carpenter's glue gives you more time to position the thing. And quite frequently, I'll put a piece of kitchen wax paper down in case there's a
Hmm.
little bit of seepage and I don't want the thing glued permanently to my workbench. We all There's something I heard one time that experience is the name we give to our mistakes. So some things I'm fairly experienced at.
We have this thing where we want to teach you the mistakes we made so you don't make them, but it creates the problem that now you make no mistakes
That's right.
and you don't learn much. So some things you just have to learn the hard way, and this is one of them.
Yeah.
The Do you know if the draft site software has an online version so that you could maybe share a design with somebody?
I'm not 100% sure, but what I've found is that any files that I've created, I can email them. I've emailed them to quite
Okay,
a few people with no problem. I've emailed them for laser cutting. I've emailed them for people that just want the drawing. Um, and it can export in quite a variety of file formats. The native format is the .dwg format, which is the
hmm,
AutoCAD format. But the export in DXF, which is a very popular CAD format, is easy. You can export in .svg. You can export in PDF.
cool.
The only thing I must mention that my standard version doesn't include is the ability to import a PDF into a layer.
Okay,
So I guess they want more money for the PDF, but there's workarounds for that as well. That in 3 years of using the program, it's the only thing I would have liked to have done that I couldn't do. The rest of it is great, and the program in 3 years, touch wood, has never crashed. It's
oh wow,
very, very stable.
wow,
No matter what I did or screwed up, it's still there. So,
cool. Well, thank you very much. I'm going to ask you the last question, which is the most important one, but probably leading to another clinic, either by yourself or someone else. What type of laser should I look at for the hobby? CO2, diode, what kind of wattage?
well, I think for that you need to probably ask my friends Greg Williams or Alan Welch because they have the machines and they have the experience. But from what I know, a 20-watt diode laser is fine. Greg has done some parts that I gave him the artwork for, and he's cut them with the 20-watt laser. For instance, sides for caboose, and they came out beautifully. And it has more than adequate power for the relatively thin materials that we are using.
Cool.
But
Oh, last one, last one. Did you consider using commercial parts for the interior details? Sorry, that one slipped in.
yes, I did. But I was also trying to complete my AP structure certificate, and I thought it would be better to try to make as many as I could. And then I kind of got into a sub hobby of my own, and I was having a lot of fun, so I just made them all. And actually, when you do something like that, yes, there's commercial parts for practically everything that moves. But if you make the part yourself, first of all, most of those parts I made are not difficult at all. They're just simple
Okay,
little projects. And it will increase your construction score, and it will increase your conformity probably, and and so on. Basically, um, the more you when as people know, when you're evaluated for AP, the fundamental question that's asked is how much did the modeler do themselves, and how well did you do it? So there's a scoring matrix, and if you had a very simple model poorly done, that's a lower score. A complicated model extremely well done is a high score. So it's all what you want to achieve. And
correct.
I had fun with this, and I really enjoyed the interior part actually more than anything else, I think.
Cool. Those sub projects, Martin told us we call them rabbit holes.
That's about it, yes.
So before you leave, I just want to say thank you for everybody who joined. We're skipping July because half of us are going to Evanston for E24, and all of us are going to Long Beach for the national convention. So there's still time to register if you want to meet us there. So enjoy your summer, or if you're in the other half, winter. Um, See you guys in August.
Nice to see you, Speed. Thanks very much, and goodbye, everybody.